So next we're just gonna plot our points at 0. We don't care. We care what 20 degrees Celsius, 20, 25. I'm not sure if we should do it this way, so I'm not gonna do that because yeah, we can do this, but it's just gonna make everything clustered to one side, and I don't want that. So instead, we're gonna have 20 here, 25, 30, 35, 40. As you can see, they gave us a perfect amount of points for this question. So I guess just do it. We have 10, so 2, so 1, 2, 3, 4. That's our first point. 25, we're plotting it at 46, so 1, 2, and 3. 30 is 74. As you can see, we do need the 80 point as well, so that's good. At least we're covering everything. 74 is the fifth part. 1, 2, 3, 4, 5, 6, 7. Okay, and 35 is not necessary. We need 40, which is 59. So go right there, and 45, which is 42. So now we're just gonna connect the plot. You do not have, see, if it was a bar graph, it would be more like you would know if it's a bar graph. It's not, so don't gotta worry. Okay, and most of the time, if they want a bar graph, they would ask, because I think they ask you to draw histograms. If they ask you to draw a histogram, they have to differentiate. So M1 is a slide of a transverse section through a leaf. So draw a large plan diagram of the whole section on M1. Okay, we can do that. So we're gonna start off. We're just gonna find our what is this called again? It's microscope slide images. Microscope slide images. Ah, shit. Okay, so I'm just gonna open my folder. I'm gonna open my folder. In my folder, I have a thing called microscope slides. And yeah, it's just a bunch of microscope slides that I can use. So since I don't have the actual images, it says transverse section through a leaf. So I'm just gonna find a leaf. I found one, but I've already done that one, so I'm not sure if I want to do it again. Instead, we're just gonna straight up find a different one. So I can't find anything here. Instead, I'm just gonna search up transverse section through a leaf. Okay, so and I'm just gonna add microscope slide. So we're not gonna be using this online stuff, so we have an idea of what to draw. We might not be able to completely identify everything, because again, ours is gonna be completely different, right? But it's okay as long as we are trying to understand. Okay, so I'm gonna be using this photo. This photo. Wait, give me a second. This photo. So I'm just gonna take that and I'm gonna try drawing that out. So the tip to draw these is to just not overlap your lines and just wing it. So for this situation, we're just gonna connect from one point and we're just gonna follow it. I think drawing it big is no problem. A lot of times I'll draw it small, but it's mainly because I'm afraid to mess up. So just don't do that, because you're just gonna, if it's small and you spend so much time drawing on something small and you find out, hey, I can submit a small drawing because it needs to be at least 6 millimeters or 6 centimeters. And on top of that, you also need to take into account that you need to draw the cuticle, and if you erase everything, it's going to look bad. So even if you make a, just stop worrying too much about making mistakes and focus on drawing the overall picture. See, in this picture, yeah, it looks, see, if I make this kind of mistake, I'm not gonna spend hours trying to fix that. No, I'm just gonna go one more time. Okay, now I'm gonna draw this to represent the xylem and the phloem. And again, the palisade mesofilm goes like this. Done. And I'm gonna do one more like that and connect upwards. And I'm gonna do one more at the bottom. And no, the bottom part is not the cuticle. The bottom part is the lower epidermis. Speaking of which, we're also gonna draw another layer at the bottom. Uh, when doing this paper, I think choosing the right mechanical pencil or choosing the right tools is important. Don't use like one of those pencils, like pencils like this. They're like are flat edged, and you're gonna completely mess up your drawings. Don't do that. So I'm using a 0.3 millimeter mechanical pencil. It's pretty good, but it can break at times. So again, be careful what you're choosing. Now this is what we have drawn, and you can include stoma, but I don't see no stoma there, so we're not gonna include that. And remember, we're not gonna label everything, just one single part, which is the palisade tissue. So we know as our palisade tissue in drawing, the palisade tissue is smaller than the spongy mesofilm. So we're just gonna write here. We do not want to overlap the lines, so I'm gonna write right here. Palisade tissue. Okay, palisade tissue. Okay, that's all, and we're done. And that's pretty much it. We got our entire drawing done, and we don't have to label anything else. We're done. Now the next question is, observe the upper epidermis on the M1 and the layers of the cells beneath it. So pretty much upper epidermis and the lower part. Okay, it says here, the large bulge on the midrib is located on the upper epidermis. Select a group of 4 adjacent cells. This group must include 2 cells from the upper epidermis and 2 cells below the epidermis. Each cell must at least touch 2 of the other cells and make a large drawing. So, it says a large bulge is located on the upper epidermis, and we're not taking a longitudinal section. We're taking a transverse section. So if we go like this, we're just cutting it. The midrib will just be there, and it says here it's located on the upper epidermis, so that makes sense as well. That's why it's like an indent, I'm assuming. That makes sense. This group must include 2 cells on the upper epidermis and 2 cells from below the epidermis. So the thing is, I feel like to a certain degree they're trying to confuse us by trying to include other terms. We don't have to worry about that. I think just focus on drawing the 4 cells. 2 are going to be smaller and 2 are going to be bigger. And even if you look at the drawing, if you try to zoom into the photo itself, we will only see the 2 cells and these 2 longer cells, vertically longer cells below. Each cell must touch at least 2 of the other cells. Make a large drawing of this group of 4 cells. One rule label line to identify a chloroplast in 1 cell. Okay, so this is a detailed drawing, and interestingly enough, we have to draw everything. But I'm just worried because if I do a detailed drawing of everything, how do I have to also include the rest of it? And that's a bit confusing, but I think I can make do. It's just I need to figure out what to do. It says the mark scheme says minimum size, no shading. Okay, let me just mark this real quick. I need a pen. Yeah, I got my pen. Minimum size draws the whole leaf section and no cells drawn. That's good. We draw the correct shape of the palisade tissue and the correct shape of the vascular bundle, and a label line and label the palisade mesofilm. So this should get palisade tissue. This should be right. Again, I don't have any of the slides, so it's a bit sad, but I am gonna ask my teacher tomorrow, right before the paper, to see if my answers are right. I'm actually gonna send these to her later and get my results back, so hopefully that's gonna be good. Now we're gonna do this part. It says you need a minimum size. Okay, that's valid. Your lines are sharp and continuous, so you get marks from those. You draw 2 cells from the upper epidermis and 2 cells below, and each cell touches at least 2 other cells. That goes just from the instructions, so you immediately get marks from those. You draw the correct shape and size. You draw the chloroplast inside the palisade cells. Again, palisade cells, as I said, and label line and label to 1. So it's pretty much the same thing. Nothing crazy really. Just gonna draw one cell. Okay, one roundish cell. The thing about the upper epidermis, the cells are round. They're not very long. So you're just gonna draw something like this. Yeah, like that. But remember, yes, this thing is shared, but you want to make sure it does not look overlapped. Overlapping is gonna make you lose the mark. So this is actually the touching point. So you need to draw one more, because this is the cell wall. Plant cells always have cell walls, so you always have to draw an inner one, so that just looks like it's touching. If you don't do that, it's just gonna look like they're overlapping, and it's bad. And in all honesty, this is not great. I'm gonna keep it a buck. That is not a good thing. So I'm just gonna erase this part. See, this thing, I'm just worried because it says in the guideline, the learner guide, it says no overlapping. And if I do an overlap, I'm worried this kind of thing is gonna make it seem like it's overlap. So I'm just not gonna do that. I'm gonna confirm again, and I'll tell you guys if that happens. Okay, now see, they said it needs to be touching at least 2 other cells. I don't care about it. At least I'm just gonna draw 2 cells, all 4 cells touching. This pretty much means I'm gonna not worry about that mark. And I'm just gonna draw one long cell, at least 2 other cells, and yeah. So it's touching, it looks fine, and we're gonna do the same thing for the other cell. Try to trace along that line, and then another cell, touch that part, and you just want to trace along the original line, and boom, and draw a longer cell. And actually I don't want this thing to be there, so I'm gonna erase that. While erasing, make sure you try to get as much of it out, because when you don't do that, the examiners are gonna know that you traced it multiple times, and they don't like that. It needs to be like you didn't do that. So even if you have to use the back eraser of your mechanical pencil, try to get it out. Okay, now I'm trying to draw cell wall. So once you draw the cell wall, you need at least 3 lines. This is very crucial, because if you do not draw, and see, this is bad, that thickness should not be there. So I'm gonna try to fix that as well. You all might be wondering, is it this necessary to do all this? Maybe not, but at the same time, I'm one of those people who I don't like risking my marks, so I'm just gonna draw it properly. See, that's bad also, another form of shading. See, the thing is, we do not know how strong, we are an examiner, the examiners are outside of, however they mark is not our control. So we just have to try to be as careful as possible, and just have to be cautious, because yeah, it might not be that hard or strict, but we might have some difficult examiners, they might go like, hey, no, this drawing is bad. So hence, we don't have to draw a vacuum. I do not think so, because as said, observe the upper epidermis and the layers cells beneath it. Okay. The large bulge on the midrib is located on the upper epidermis. Okay. See, I'm just gonna draw one large circle, just like this, and that's all I'm gonna do. This is not a cell. This is a cell structure, and they asked for it. I'm not gonna be drawing it. You're wondering why I had to draw cell walls? That goes without saying. Plant cells, it's just like how you're drawing a cell membrane. You have to draw the cell wall. So I'm gonna say this is a chloroplast. Hopefully this gives me full marks. I'm gonna be checking my teacher later, so if you all want to know, just like ask me in the comments and I'll tell you guys. I don't know. This is my first time live streaming. I haven't even checked how many viewers yet, but whatever. It's not important. Anyways, this is the next section. It says transfer section of a different leaf from M1. The difference is I don't have the M1 slide. I'm assuming it's the one I have. It looks like this. So we're just gonna have to make do. It says identify 3 observable differences other than color between the leaf section on M1 and the leaf section in figure 2.1. Okay, so this is another transverse section, and pretty much it's almost the same. It's just a different type of leaf. It's like this section. So if the leaf is this way, we're cutting it right there. The leaf, we're cutting it like right there. Boom, boom. So that's why. So that's what we have. So we're going to talk about, other than color, what can we talk about? The vascular bundle is still central, so we can't say anything about that. I would like to mention the presence of stomata, but that's also something I'm not sure. Actually, I think I can. I'm not sure because I don't have the original one, but there's one here and there's one here. And there's two on the upper epidermis and the lower epidermis, so I'm definitely going to include that. And what else? What else can we see? This large air spaces. This is definitely, most probably not present. We'll find out sooner or later. This is definitely not present, so this is important. And there are giant air spaces, and I'm gonna say, don't really want. I want to comment on the vascular bundle, but I don't think I should. But I'm just gonna think of one more just so we can finish it off. I want to say the midrib runs across the vascular bundle, but I don't think that's gonna be the right answer. Okay. So I'm gonna say the there are palisade cells on both sides. I'm gonna say there's two palisade tissues, like two layers. Okay, I'm gonna find out the answer and we're gonna see. Okay, shape of vascular bundle. It says this is flat. Okay, so again, I didn't have the original one, so I can't really know, but that was flat apparently. So if you drew this in a specific way, so I'm assuming if it was like flat, let me search on a flat vascular bundle. I don't know what a flat vascular bundle would look like. A vascular bundle, microscope slide. So according to this, it says, what? Oh, no, that's not it. Leaf. Okay, interesting. Flat. I'm gonna put flat versus oval. That's definitely gonna be something else, I think. Okay, let's see what we have. Says vascular bundles is there and there. Interesting. I'm gonna look at my sample slides to see whether it's similar, because I don't know. It's an interesting question, not gonna lie. It's quite interesting. Leaf. If y'all like have any questions, like drop them in the chat. I don't know if I'll like reply immediately, because again, this is my first time live streaming, but I'm just trying. So I'm assuming that when you draw the original one, the vascular bundle would look kind of flat, like very like flat. Like it would not look like a circle. It would look more like squashed. So nothing we can do about there, but it's good to know that that's something we can talk about. So another thing I'm gonna write it out on the side, on a small card maybe. We can talk about the shape of the vascular bundle. So one of the things we can talk about is the shape. The size, not really, because we don't really know the relative sizes of each one. Palisade tissue, maybe like the proportions, maybe. Okay, palisade tissue. Again, yes, we got this one right. Upper epidermis, bulge, midrib, leaf, microscope slide. I don't really know how they expect us to practice paper 3 if we don't have it at home. Okay, so interestingly enough, we definitely got most of it right. A bulge in your thing, as what we drew, actually has a bulge. This thing, that's a bulge. And if we look at what a bulge in a midrib would look like, it would look like that. So we did draw the right thing, and we got a decent slide from the internet. That's great. And we're just gonna write that down. So the bulge is present, and it's because of the midrib. So I was thinking of that, but at least now we know. Feature mentioned in the question. So if they mention bulge, I guess when they specifically mention the bulge, I guess we can think about that. So we definitely got one. And it says the leaf blades are thin versus thick. So that means this again is not a perfect representation. Maybe it was much thinner in the original slide. Yeah, it must have been much thinner. But I don't really know how the original slide looks like. Let me refer to another source. Maybe I can find it. I think I have it on the side. Do I need to open this? Okay, I don't. So, flat vascular bundles. Where are we looking at? Okay, it says vascular bundle, but I don't see nothing. Oh, okay, that's not very helpful. I'm trying to find it. I don't know what I'm looking at. Flat vascular bundle. Thick one over here. Maybe it was thinner. Depends on what you get in the microscope slide. But really, you don't only have to talk about the tissue. You can also talk about the shape. Okay. So you don't only have to talk about the tissue. You can also talk about the shape, as seen in the Mart scheme. They also mention my computer is lagging. That's not great. That's not good. Close the tab. Okay, so according to the Mart scheme, it says this one was really thin, so we just have to assume this is quite thick. And compared to the other one, thickness. So we can talk about the thickness of the leaf and tissue. So the tissues, but the tissues we don't really know much about that. The air spaces, however, is not an answer. I'm gonna ask my teacher, and if you all want to know, just like drop it in the comments later or something. I'll like tell you. Air spaces, I don't know why. That's not an answer. Okay, so now we have the last two. We have the thickness, the bulge, and that. So first of all, the shape of the vascular bundle. Shape of the vascular bundle. So the first one was flat, oval, and we have the palisade tissue. Okay, this one we got right. So it says upper epidermis and lower epidermis. I'm gonna say it's like below the upper epidermis and above upper epidermis. Below upper epidermis and above the lower epidermis. Because I don't really understand putting upper epidermis and lower epidermis. If I was the examiner, I would mark myself wrong. Bulge. Okay, so this bulge is mentioned in the previous section. So we just have to say the bulge is present and absent. Yep. And the lamina. So you can say leaf blade, but you can say the lamina is thin here and thick. So really depends. If you have like your own like lab manuals or whatever, that's also gonna serve really handy. Okay, now my favorite part about this paper is the only thing that is super easy. Hopefully I don't get this wrong in the exam. Measure the thickness of the leaf using the lines P1, P2, P3, P4, P5 and find the mean length. So it's pretty much quite simple. If the length is different for you guys, it's probably not that big of a problem, because the truth is your printing is also going to cause it to look different. So I'm just going to convert this into millimeter. 1 centimeter is 10 millimeters, and I'm just going to include this because you have to include the unit. Never mind. that goes without saying. 4.2 cm equals to 42 millimeter, and P3 is 5.5 cm. If it says 5.51, you don't have to say that. That's a waste of time. What a horrible sore throat, man. Okay, it said I got 3.6. Okay, 3.6 centimeters, so it's 36 millimeters. And P5 I got 2.5 centimeters, 2.5 centimeters, so it's 25 millimeters. The mean length equals to 27 plus 42 plus 55 plus 36 plus 25 divided by the total of number of lines, so 5, and you would get 27 plus 42 plus 55 plus 36 plus 25, which is 185 divided by 5. So this is 37 millimeters. That doesn't seem right. No, that makes sense. 37 millimeters is only 3.7 centimeters, so it's correct. It's a thick leaf, man. But this is magnifying. I don't know what I'm saying. Using the magnification and the mean length of lines, calculate the actual mean thickness of the leaf. Okay. Okay, first of all, we're going to use image length equals image length divided by magnification equals to the actual length, actual thickness. I'm just going to copy the question in that sense. So the actual thickness equals to 37 over 25. 37 divided by 25 is 1.48 millimeters, or times 1,000 will give you 1,480 micrometers. But I'm just going to write in millimeters. They didn't specify the unit, so it's fine. And it says here, correct measurements of lines P1, P2, P3, P4, P5. Hopefully it's right. Shows the addition and divided by 5. Shows the division of the mean length thickness by the mean length. So instead of saying image, I guess I could have said mean, but it's just saying you need to use this value divided by the thickness. So that's right, 1.48 is what I thought. Whether the specifics are right really depends on whether my answer is similar to the one in the mark scheme. This is right. They just ask you to plot. Okay, I didn't check this. It says here the x-axis is a temperature of degrees Celsius, and the y-axis is rate of reaction, arbitrary units. The scale on the x-axis needs to be 5 degrees Celsius to 2 centimeters, which is good. It's 20 at the origin and labeled at least every 2 centimeters. It's great. So we actually changed it and we got it right. What if you weren't here just now, what I wanted to do was to put 0 and then 20 and 30, 40, 50, 60. But that's a bad idea, because you're just gonna no, so I think I said 10 or something. But it's just gonna shift everything to the right, and your graph is gonna be like half of the space, which is bad. So that's not what you're gonna do. The scale on the y-axis is 20 to 2 centimeters. Again, that's right, beautiful. And labeled at least every 2 centimeters. So every 2 centimeters labeled, even until the end. Don't worry about it. The correct plotting of all 5 points using the dots in circles or small crosses. My crosses are present. 5 plots joined with a thin line passing through all the points. Beautiful. Next question. So I didn't have any of these, so I just assumed the values based on my knowledge. I just assumed the knowledge because technically when I did this in class, it's around that. Sometimes it could be more than 120 seconds, so I just put these values in. Again, really depends on what you get in the exam, like whatever time you get. Reaching the temperature of the water bath. Reference to the. Could you all see that? The graph. Damn, I'm sorry guys. I didn't know y'all couldn't see that. Hopefully that's better now. I mean, whatever. Next section is this section, temperature. So 1A2 is in the previous page. Okay. So temperature, yeah, I want to say equilibrate. I don't know if that's right, but it should be right. It's just to make sure the temperature of the amylase is equal to the temperature of the water. The Benedict solution is the right answer, and you want to use the same amount of Benedict solution, and you want to heat it up in a water bath, heat it to 80 degrees Celsius, and you just put it in a test tube. And then the highest amount of reducing sugar is the one that had the shortest time. Yeah, and other than that, you have the next section. Yeah, this part is done, and this section is about temperature. So temperature is the independent variable in this situation, in this investigation, because it's interesting because sometimes you might think it's the concentration, but it's not the concentration, mainly because they're just talking about put 2 centimeters. It's a constant variable. It's not changing. So we don't care about that. What is changing, however, is the 0 degrees, is the 40 degrees, and the 100 degrees. So that's the independent variable. And another thing is, when you are drawing tables, it's very important to make sure that you include the independent variable and not the test tube. I put the test tube, and that's not right. You need to put your heading for the independent variable as temperature. You need to put your dependent variable as your time, and as well as the color with starch, mainly because they put it in the experiment if any starch is present, so you need to include that. This I should not have included blue black because they said blue color, so I'm just going to include reduce that, take it out. Never mind, I know what I'm saying. Time, reducing sugar for each sample, and a color for each sample. As long as I included a color, I should get marks. And the reason, hopefully this is right. I don't know whether, I mean, it really depends. Hopefully in the experiment I won't have to assume anything. I'll get it done. Correct sequence for reducing sugar based on the candidate's result. As you can see, I said starch. That's why I put it's present, and you can see that it is the time taken is decreasing. So because it's decreasing, this is because of temperature, not the concentration. So because of that, that means the amylase is working more, resulting in more reducing sugar. So this is correct. And this is none, because in reality that is 0 because the enzyme has denatured. Presence of starch should again be like this. This is right, and the correct sequence starts based on the candidate's results. Since I put blue and blue, I have to put present for those two. And the last one is the last question. It says explain the results for S1, S2, and S3. So for this one, it's again kind of weird. They just talk about how the S1, the enzyme hydrolyzes starch, some starch. Here the enzyme hydrolyzes some starch, and here no starch is hydrolyzed. Yeah, enzyme does not hydrolyze the starch, and I have to compare. So I did include the enzyme substrate complexes formed between S1 and S2, less enzyme substrate complexes, and here I put most. Same thing. It's a comparison, but I'm just gonna say more next time, because you only compare the two. There's only 2 times the enzyme substrate complexes are formed. Correctly compares the hydrolysis of starch between S1, S2, and S3. So I did not say S1, S2, and S3. I did not say hydrolyze. I said broken down, but I said broken down. So next time for starch, I had to say hydrolyze, and most starch broken down, no starch broken down. So I would get my marks. And yes, the truth is, there are 5 total points, and I wrote 3 marks. So technically, I will get my 3 marks because I included the comparison of the breakdown, and as well as the S3 enzyme is denatured. So I will get my 3 marks regardless of whether I missed that point. And the last but not least is record a time for color change, for color starch for you. Yeah, see, I didn't know what to say, and I put yellow because it completely broke all the starch, hydrolyzed all the starch. And temperature for the water bath, I put 30 degrees Celsius. I'm gonna confirm this, but yeah, that's what I put because I don't really know. I can't really put much, but that's what I have to do. So that's one paper done. This is the 35ON 2024. That's pretty much it. So we're going to be moving on to the next paper. I want to start my STEM lab manual, but the thing is, I don't know if I want to start that now or later, but I definitely have to complete that by today. A bunch of other things need to be completed, so It's gonna be a long day. The reason why I'm actually streaming is not because I have like some knowledge to pass on. It's just because like this is helping me to focus and not get distracted by other things. Okay. Okay, we can definitely do this. Different paper. This is the 33ON, and we could be doing this now. But I don't know, take a break or something. We're gonna be doing. We're gonna go through some of the. I'm gonna go take some photos and send to my teacher, asking some questions. Hopefully, things go down. Things are okay. So this is the next question I want to ask. Where are y'all from? Whoever's watching. I don't know if the chat works or not, but hopefully it's okay. Oh, this is done. I have my photos. Let me ask the. So we also finished this paper, the February March 2024. Yes, we also finished this one. Do you have any questions from this paper? Okay, so this is another thing I drew. I'm gonna ask if it's right. See, this is just another drawing. It has no really reference. It's just I want to know if the drawing itself is not bad. This is, I think, a flat vascular bundle. This is a flat vascular bundle. I think. I don't really know. This is the original drawing isn't very super clear or something. It's just quite simple. But I think I don't really know. Let me send the picture. The picture looks like this, in case y'all are wondering. That's how it looks like. Yeah, I don't really know. My teacher responds kind of fast, so it depends. I'm gonna go forward all of this to her. Don't, like, if you guys, all the best for tomorrow's paper, man. Tomorrow's gonna be crazy. I'm actually really worried. I'm not the most excited for tomorrow's paper, but it is what it is. We worked hard, it's been so many months studying, so I guess it's the moment of truth. On the stream, it's not, you can also use AI. If y'all are wondering, hey yo, 2 people. Damn, sorry guys. It's kind of crazy. Hello, new viewer. No, not the stream is not paused. I'm just waiting for the. We're just gonna check some answers with my teacher, and we're gonna see if we're correct. No, the stream is again not paused. We're gonna be back soon. In maybe like 2-3 minutes, so that should be fine. 26.25. Hello, new viewers. No, the stream is not paused again. We're just gonna clarify some questions with my teacher, and hopefully we can continue with the next paper. Yep, that's all the questions. Sending. Yo, people be just popping in and popping out though. It's funny. Thanks to whoever stays Appreciate you. And the 6 guys who stayed, or 6 girls, I don't know, guys, gender neutral, I don't know. Thanks for staying, man. Oh shit, y'all left when I said that. Damn. Good, it's good. What's whatever, you know. It don't really matter. Okay, so we're gonna get back to the next paper. Okay, so we've completed 3 papers only, and I'm not proud that we got more to do. So 1, 2, 3, and we got the next paper. So the 4th paper. So the goal for now is currently 3:19. So we're gonna aim to finish another set of papers, another couple more papers. We're gonna do one more paper and we're gonna go through the lab manual. I want to get the lab manuals done as well as this done by 6 o'clock. Oh wait, 6 or 7? 6. Yeah, 6 o'clock, I think. Wait. Let me check my calendar, see when I'll have to end stream. Man, so much to do. Chemistry. Yeah, 6:30. I have to leave. So till then, we're gonna grind. We got one more paper to do. Let's do it. Okay, the first thing is let's open the mark scheme so we can immediately refer to our answer. If we know the answer, I think we have to like quickly move on. We have a lot to do. I have like a checklist of things I have to do, and we are not on track. Damn, it's only 3 o'clock. I'm passing by so fast. Whatever. Okay, next we'll do this. We got 7 viewers. Whatever. It's fine. It's fine. It's fine. Focus. Anyways, plant cells produce enzyme catalase. This is the 33ON 2024. In case anybody is wondering, 33ON 2024. In case you were wondering. Okay, so the plant cells, they produce the enzyme catalase. This catalyzes the hydrolysis of hydrogen peroxide into water and oxygen. Yes, the cylinder potato tissue will have catalase molecules on its surface. When potato tissue is put into hydrogen peroxide, oxygen bubbles are released. Okay, when potato tissue is put into hydrogen peroxide solution, oxygen bubbles are released and a foam forms at the surface of the hydrogen peroxide solution. You will investigate the effect of ethanol concentration on the activity of the catalase by measuring the height of the foam. Okay. To be honest, I'm not doing this anyway, so it doesn't really matter if I write it properly or not. But I'm just going to read it so I know what to answer in the questions. The length of the potato cylinders may not be precisely 4 centimeters. Identify one source of error in the procedure you have carried out. Okay, I'm going to say the level of the foam is not level, and some bubbles are larger than others. So the top of the foam is not flat, so it's hard to measure height of foam. I'm pretty sure this is a solid answer in my opinion. Hopefully we are right. Okay, the answer for this question is none other than measuring the height of the foam. Okay. Well, we explained a lot. They said identify, so I'm right. So it's hard to measure the height of the foam. That's the right answer. I'm proud of that. I think that's good. You will investigate the effect of concentration, ethanol, serial dilution, and 100% ethanol, E to reduce the concentration by half, between half serial, so they're telling us the factor. You will need to prepare 3 concentrations of ethanol in addition to the 100% ethanol E. After the serial dilution is completed, you will have 30 centimeter cube of each concentration available to use. Okay, I have 30 centimeter cube of each concentration. Okay, yes, that's good. You will need to show how you will prepare your serial dilution, each beaker should have a label arrow, a label under the beaker, and a label arrow to show the volume of distilled water, and a label arrow to show the volume of the ethanol transfer. Okay, so first off, I'm gonna immediately put in this section. So they need 30 of each. So I'm gonna say 30 centimeter cube of 30 centimeter cube of 100% ethanol. 30 centimeter cube of 100% ethanol. And next is the water. How much water do I plan on adding really depends. So it says 0 centimeter cube of water, but I have to add 30 centimeter cube of water. The reason why is because I'm diluting it by half. So now this is now 50% ethanol. Now we're gonna draw one more arrow, draw a nice curve down. We're gonna write there 30 centimeter cube of 50% ethanol. So draw this down, and we're gonna write that 30 centimeter cube of water. So 25% ethanol. Now the next part, we're gonna draw another arrow and draw this. Okay, now this part is interesting because they want us to have 30 centimeter cube of each concentration available to use. I think we can do what we normally do because as long as it's available for usage, it should be fine. Okay, so our teacher replied to the message. We're going to be going through all the doubts really quick in a couple of minutes. 25 divided by 2 is 12.5% ethanol. Okay, done. So this should have 30, 30, 30, 60. And what's the answer say? It states 50, 25, and 12.5 shows the transfer of 30 centimeter cubes to each beaker from the previous beaker. Okay, 30 centimeter cube of each beaker. Okay, yep. And shows 30 centimeter cube of water added to each beaker. Boom, boom. So we get the mark for this question as well. Heading for infant. Okay, so this is another question. I don't know if my teacher replied. Let me check. Okay, so she's still replying. She said pick one. I'm gonna show y'all real quick what I asked, and y'all can tell me. So the first thing was this question: planning and investigation. So over here, I had a doubt on whether my investigation was right or not. Here, I didn't know if my investigation was right, so I asked my teacher what was the mistake. She said, if you want reducing sugar, why are you using sucrose solution? So that is immediately wrong. I don't know. I have no clue why I did that. Okay, so this is wrong. First of all, that's a good thing to take into account, is that you can't just say whatever you want. You know, this is wrong. Glucose. Cell drawing is okay, but you don't have the question. Plan diagram. Okay, so I sent her these questions. Just trying to show y'all. Let me see. Yeah, I sent her this. So she said, for this question, my drawing is correct. Second one, she said she doesn't have the question, so she can't really tell, but the drawing is correct. The method, like everything is right. She said this is a plan diagram, I believe. This is a plan diagram. She said good. It's correct. So far so good, guys. She's gonna be asking. She's still replying to my other questions. I'm gonna ask her though for the third pick I showed just now. I'm just gonna ask her real quick. I don't know why I can't. Teacher, where is the vascular bundles in this question? And also, what does a oval versus flat vascular bundle look like? Okay, so I'm sending it, and yep. Okay, so while my teacher is taking her time to reply, I'm also going to do the second question. For tables, you want to use a pencil. Yeah, we're in this better view now. For tables, you want to use a pencil. So it says here, put 1 potato cylinder into each beaker. Prepare the concentrations of ethanol as shown in figure 1.2. Concentration ethanol, figure 1.2. Okay, this one. It says put 1 potato cylinder in each one. Label the test tubes with the ethanol concentration prepared in step 8. After measure the height of the foam after 1 minute, after 2 minutes, and record the results in A3. Okay, I'm gonna put this one. First of all, I want a good line. I used a set square just now for this to draw the table. Do I think it's necessary to use a set square? No, because it's practically useless. I still had like slanted lines, so I don't think it's any use. But is it better to make sure you have straight lines for your tables? Yes, 100%. Make sure you use tables, draw tables in pencils, not pen. What you write inside the tables, you can use pen. But outside, no. Now the next one we have to write. We have to draw 3 columns for each one of the datas because we have 3 different sectors. Make sure you guys get a solid ruler, not like this plastic trash. It's garbage. Anyways, we have our table now, and we're gonna put there. The first one is the concentration of ethanol. Concentration of ethanol, and the unit is in percentage. Here is height of the foam after 1 minute, so we can measure this in centimeter or millimeter. It doesn't say, so I'm gonna say millimeter because I don't have to include decimals. Height of the foam after 2 minutes. So understanding that they want us to find it after, they probably don't care about whether it decreases, more like it should increase. And remember that the amount of concentrations we have to do is 1, 2, 3, and 4. So 4 in total. So we're gonna draw 3 lines. 3 lines. 1, 2, and 3. So this should give us 4 lines. So we have all our lines, and it's time to write. We have 100%, we have 50, we have 25, and we have 12.5. We now have the height of the foam. So for 100% ethanol, so let's just read into the question real quick. What's the point of ethanol then? Oh, so it says the effect of ethanol is to reduce the ethanol, okay? So it doesn't tell us the effect of ethanol on the thing, so we just have to assume. So I'm gonna just see. We don't really have any data for this, so whatever. It says here, heading for the independent variable, which is our concentration of ethanol, we get 1 mark. Heading for the dependent variable, height of the foam, millimeter. This is great. We use millimeter, and that's the right answer. States results for the 0% concentration ethanol. Where did I include that? And did it ask for that? Gang, what? Bro, what? Concentration of ethanol? Huh? Okay. I think I had to do that previously or something. Prepare the concentrate, put one potato cylinder, start timing, label the test tubes, put 5 centimeter. Oh, label 100. So they asked us to do one completely without any ethanol in the experiment. So that's why, guys, read the questions. Really important. It's really important. It's really important. 12.5 and 0. Okay, so we're just gonna be asked. I'm gonna be answering the questions that we have. Okay, so the next one is the bar chart. So bar chart, you have to include axis titles. Starch grains look like circles, ovals, nothing inside. Okay. Pick 4. What did I send in the fourth picture? Source and error. I think I got that right? Yeah, she said a small. Yeah, great. Pick for the key. I think they want you to write symbols. So for the fifth picture over here, let me just show y'all. Show the key you will use. Okay, so this is ridiculous. So pretty much in this question, they want us to find they want us to use a key, right? And I was like, what key? So they just want you to complete it, and you just want to, include how many variations do you want to make, and most, least, and okay. From the photograph, which is very blurry, most likely a small circle you drew. I don't understand your question though. What do you mean? What is a flat vascular? Maybe one looks like an oval, like a pill, thin but tall, and the other looks flat, like a pill but sideways. What am I showing you? Oops daisy, oops daisy. Shoot, I didn't send it to her. That's the problem. I didn't send her the question, so she doesn't understand what I'm talking about. So, this is the question. They want us to do this, and I'm gonna get the answer. You can answer my questions. Okay, so this, we don't really have anything for this, so I'm just gonna move on. Calculate the rate of which the form. You can't really do much there. Use your results and describe how the rate changes with time. Again, I don't have the results. Shows how both rates are calculated. Sadly, you can't really do anything about that. With reference to the activity of catalase, explain why the zero were important. It acts as a control. Shows the activity. Don't say it. Okay, reference to the activity, so I can't just say it's a control. Shows activity of catalase with no ethanol present. So the problem is Damn. You got to be careful with this. Okay, so it says with reference to the activity, I can't just say it acts as a control. I have to say it is a it shows the activity without any ethanol present. State the dependent variable in this, the height of foam. Yeah, I got that right. Okay, good. Height of foam, great. Suggest 2 improvements to the investigation you have carried out to increase the confidence in your results. Okay. Okay, so let me see. This is for a specific experiment. Let's see if I have this. It's for enzyme. Enzyme. So for enzyme, use measure the volume of gas. So we can use to measure the volume of gas using a gas syringe instead of measuring the height of foam. That might be good. Use wider test tubes. No. Control the temperature. Teacher, that is okay. So improvements. I don't know what's the answer. Oh, okay, that's interesting. See, this question, which I kind of did this. So my teacher really cannot answer that question because there's not much to dive deeper inside. Rest all is fine. Okay. Next up, we got the improvements for the paper 3. So I don't know how the answer is going to look like, but let's find out. The answer says more concentration of ethanol. Carry out repeats and calculate a mean. Use a gas syringe to measure the volume of gas. So we did get one right. So we got the volume of gas. To measure the volume of gas produced in like for foam and shit, they said to use a gas syringe. So that's good. Other than that, let me see if I have any like let me see. I think my teacher's getting kind of annoyed. I'm getting fried by my teacher. Okay. 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 I have a really bad sore throat. And I just like something really supposed to stop the stream and like continue or like drink some water. So I want to drink some water and come back, man. Never mind, I have no water in my room. Okay. Suggest 2 improvements to the investigation you have just carried out. So the 2 improvements is the one, but instead of measuring the height of foam, use a gas syringe to collect the volume of gas, and also you can calculate a mean. No, what did they say? Something about the mean and plot a graph. I think it was that. It says carry out repeats. Okay, I'm just gonna write this down. First of all, carry out repeats. Calculate a mean. Number 2 is to increase more concentrations of ethanol. So by this, it sounds. I thought they meant like add more, like in chemistry, but that's not what I don't think that's what they mean. More concentrations. I think they just mean like instead of just doing until 12.5, do until 6.25 as well. And the last but not least is the gas syringe. Use a gas syringe to collect volume of gas, to measure volume of gas. Okay, that's much better in my opinion. Some fruits turn brown. Okay, some fruits turn brown when they're cut into slices for eating. This browning can make the fruit less appealing to eat and difficult to sell. The enzyme polyphenol oxidase catalyzes an oxidation reaction when fruit is cut. Scientists carried out an investigation to see how exposing wumpy fruits to different concentrations of ethanol affected the activity of PPO in the fruit tissue. A large sample of wumpy fruits is divided into 5 equal groups. Each group of fruits is equal to a plastic container. Different concentrations of ethanol. After a short time in storage, the activity of enzyme PPO in the fruit was recorded. So you can't talk about the activity versus the ethanol. Okay, so for the more concentration question, my teacher said it more or less means wider range. So that means instead of doing just from 100 to like 12.5, do a more bigger range. Let me see what she says. I think. My phone is at a 1% right now, so I don't know how it's surviving. Okay. So this is not that bad. I love the kind of questions, but at the same time, it can be an easy way to lose marks as well. Oh, this shit. Sorry, for the language. So this is the thing, and we gotta plot the graph. So I'm just gonna position y'all so y'all can see everything. 0, 2.2, 100, 1.4, 200, 0.95, 400, 0.7, 500, 0.6. Okay, it asks you to plot the graph on the data. Okay, that's not that bad. We're gonna grab our ruler. Where did I leave my ruler? Yeah, this ruler is much better. This ruler is better, and I'm gonna be using a thicker pencil so the lines is more visible. So one line down for the y-axis. Oops, that is not a straight line. It's in between it. Okay, so next we are gonna put the PPO activity inside here. Arbitrary units, and here the concentration of ethanol. This is interesting, but I hate these units. Concentration of ethanol. Okay, so just an explanation for the pattern shown. Okay, we're gonna get to that, but first we need to do this. So we're starting off on 0 on both sides. We have 1, 2, 3, 4, and 5. So that's perfect for us. 100, 200, 300, 400, 500. This section is until 2.2. That's our max point according to the table. But that means we can do this 1 and 1 and 2 and 2.5. Great. Meaning each 10 units represents 0.5. So I'm just gonna write that down because it's kind of weird that I didn't do that. So 1.5. So now we have everything done. Well, I'm gonna put the 0 there because 0.95, 2 decimal places. I'm just gonna be more objective. 2.50. Now we have completely finished this. It's time to get into the plotting. Plotting is easy. You just need to make sure you don't make mistakes. Now we're starting off with 0 and we're all the way to the top. 2.2. 0.5 divided into 10 means each one is 0.05, and 0.2 divided by answer means 4. So 1, 2, 3, 4. This is our 2.2 point right there. 2.2. And we're actually going to draw from 2.2. We have our next point at 100, 1.4. 1, 2, 3, 4, 5, 6, 7, 8. Our next point. And we have 200, 0.95. It's quite simple to guess that one. Understanding that this is 6, 7, 8, 9, 10. This is 0.95. Amazing. And last but not least, 400, 0.7, 1, 2, and 500, 0.6 is until here. So this looks like a very nice curve, and I want to draw that, but I'm going to find out now. So the thing I'm going to say is that I want to use a curve, but understanding the mark scheme, it will also allow us to draw plot by plot. Let's just see if it's right or not. Smooth, thin line join point to point through all the points. Okay. Okay, so when the thing clearly looks like a smooth line graph, I think you just have to draw that. My graph looks trash, and I need to fix that because wow, that's garbage. Would y'all like me to stream like this for the other videos as well? Maybe for like stats, I can go through some quick papers with y'all. I think that would be quite easy. I like stats. Stats is fun. Okay, so another one. Mistake. Yeah. Oh damn, this is a bit annoying. I need to figure out how to draw this curve properly. Yeah, that's better. That's better. Oh wow, that's really nice. That's a great curve. Teacher, if they ask you to draw a graph and the points align in somewhat of a curve, draw a curve, right? Also, for questions where they provide the table data, we have anomalies, and also how, and also what is needed for a line of best fit. Will the papers specify between choosing between bar and histo? Oh, okay. Oh. So interestingly enough, it's something crazy because we drew this. The mark scheme says to draw dot to dot. Okay, that's quite interesting. I'm gonna send the mark scheme to my teacher and send her our graph. Let's see what she says. We might be getting different answers. Interesting. So for the explanation, I'm gonna say as the concentration of ethanol is increased, the activity of PPO decreases. This is because the ethanol acts as an inhibitor and reduces the formation of enzyme substrate complexes and successful collisions, enzyme substrate complexes, and hence less and less oxidation of the fruit, hence lower activity. So great, ethanol acts as an inhibitor. Concentration of ethanol increases, less enzyme substrate complexes form. High concentration of ethanol, PPO starts to denature. Okay, that's something we can include, but that's really good. That's really good. I want to take a break, but at the same time, I don't want to leave you guys here because y'all have been so loyal, waiting for me, and this being great. But I think it's time for me to take a break. But you know, in the exam, you really can't take breaks. So I think I'll just have to push through and keep going because this is the final day before the exam. As the concentration of ethanol increases, activity of PPO decreases. Ethanol acts as an inhibitor as concentration of ethanol increases, enzyme substrate complexes form, and as at a higher concentration of ethanol, PPO starts to denature. Let's check one more time. Mark scheme. Ethanol activity decreases 1 mark. Ethanol acts as an inhibitor, correct. Concentration ethanol increases, less enzyme substrate complexes form. And at a high concentration of ethanol, PPO enzyme starts to denature. Okay, we can add the enzyme at the end. Okay, guys, so for the line graph, we just found out some crucial information which we should always follow. So my teacher said only ever draw a smooth curve graph if it says line of best fit. Other than that, always draw plot to plot, and they will always ask you for bar graphs, not for histograms. So that means we're good, guys. Everything's good. You just need to connect the points. Just connect the points. If you have this, plot, connect points. Plot, connect points from dot to dot. Yeah, this is messy, but you know, you get the point. It's like so obviously a curve, but you know, there's no choice sometimes. But really, your line of best fit depends on your curve, depends on the graph. What if it's like a straight line? Would you want to draw a curve? No, don't draw a curve. Draw a line of best fit. Okay, we have the drawing part. Finally, we are leaving that part behind. So even my teacher knows that from the way I'm asking questions, I'm tired. It's kind of funny because I am tired, guys. It's been a long day, but you know, once you start the grind, you can't stop. No, I'm joking. That is intentional cringe. Okay, K1 is a slide of a transverse section through a plant stem. Draw indicated by the shaded area. Use a sharp pencil and use one label line. Okay, so this is good. I have the leaf epidermis. Again, if you all want me to send the leaf epidermis or some slide pictures, tell me in the comments. I'll be glad. Just drop in the comments and I'll think about it. No, I'll send it. Okay, so I don't really have a clear picture of a root stem, but let me see if I can find one on the internet. Okay, we found one. Nice. We found a nice picture of a leaf stem. I'm going to show y'all now on the screen. This is what we're going to be using. So, let's get to drawing. Okay, so I'll just adjust the camera. Oh, do you guys want it more zoomed in? You can do that. Yeah, that's good. Okay, so it comes to the point of drawing. We're going to be drawing this region. Use a sharp pencil. Use one ruled label line to identify. So draw this region. So they use sharp pencil. So I'm going to be using a pencil to draw a triangle. but I'm gonna let's just bring it first, guys. Okay, first off, we're drawing a line like this, like that, yeah, like that. See, again, this is one of the examples I was mentioning. It's way too like small, so make it bigger so that you have less chance of getting it wrong for stupid reasons. So you got this done and that done. Okay, good. Ah, damn, I'm hungry, man. I didn't eat the whole day. Oh, I think I did eat. I just ate really quickly, so it kind of hurts. Whatever. This is what we got. Okay, this is not bad. Now, drawing one line straight down the center. Ooh. This is not a root, this is a stem. So be careful when you draw that. So we don't care about the rest. We just need to draw two things. We need to draw, this is the pith, so we don't really care about the pith. The pith is the pith. And let me show you. This is the pith, the pith. The pith is the pith, so we don't care about it. But we have the upper epidermis, which we have the epidermis, which is this part, and it's gonna look like kind of cut off almost. The epidermis is not that thin, so this is not a valid drawing. Ah, shoot, bro, this. Okay, so this is our epidermis, and we're going to be drawing a total of 4 vascular bundles. Is that too big? Yeah, that's way too big. It's not its picture is supposed to be big, but not that, like the proportions, right? It needs to match. So make sure you're erasing all the previous lines. Okay, now we are going to divide this into 1, 2, and 3. So the vascular bundles in a stem is divided interestingly. So the vascular bundles in a stem, the stele, so it's divided into a couple different sections. What is it divided into? Is divided into, let me find the picture. The xylem is here and the phloem is here. The parenchyma is on the top, if I'm right. Yeah. This seems quite solid. Yeah, this is quite good. So it's telling you there's a xylem, the cambium, and I believe this is the sclerenchyma, and this is the phloem. So I don't really have anything to show though. Let me find. Damn. So this is under, what chapter is this? 8? Yeah, 8 for 7. 7 transport and plants. Okay, yeah, we found you. So the stem, in the stem you have actually divisions. The divisions in your is sclerenchyma, your phloem, and your xylem, and right here is your cambium. So this is your cambium, this is your phloem, this is your xylem. Sorry, this is sclerenchyma, phloem, cambium, xylem. So I'm gonna be drawing some of them like this. some of them like this. And that's it. There's nothing else. Now we have observed the cells on the stem on K1, draw 4 adjacent cells in the center. Okay, this is very fun too, guys. This is an okay question. This is one of my favorite kind of questions is the cell wall of one cell. It's so super easy, super fun. All you gotta do is just draw one cell. It's pretty much your pith. Your pith area is just a bunch of cells. And your pith area is just nothing to do much about. There's nothing much about your pith area, but other than that, it's just a bunch of cells. So just draw. You need to be touching at least 2 other cells. If that's the situation, it's all okay. Just draw it like this, and draw the other one. Oh, you didn't touch. Why did I do that? Okay. What a great question. I love these kind of questions. These are my only kind of questions I really like. And that graph question, because it's like it's the only like repetitive question. It can just be like 2 like round globular structures, and you're just gonna draw around the cell wall there, a cell wall for this section, a cell wall for this section, and after you draw, it doesn't hurt to just go and recheck to see if you have ticked off all the boxes. You know, make sure it's not overlapping. Make sure you have the cell wall drawings. See, this is not even a bad drawing. It can actually just connect also if you want. It really depends on what you have on your sting. I'm just drawing this. That's pretty much it. And you're just going to draw one label line. Don't overlap. Cell wall. Next, we have this paper. Okay, so this is a question. It's quite long. We're going to get to that. And now it says, find, okay, it's the mean length, right? Yeah, calculate the mean length of the actual, mean actual length. Okay, so this is a combined question. It's 4 marks. Let's see if we can get those 4 marks. Okay, we're going to start off with the first part. We have 2.1 centimeters. 2.1 centimeters, which is 21 millimeters. We have M2, which is none other than 2.4 centimeters. We have this part, which is 11.5, 1.15. 1.15 centimeters, which is 11.5 millimeters, and M4 is how much? M4 is 1.65. 1.65 centimeters is 16.5 millimeters, and M5 is 2.35 centimeters, 23.5 millimeters. Okay, now all you gotta do is simply just mean image length equals to 21 plus 24 plus 11.5 plus 16.5 plus 23.5 divided by 5. So just add it all up. 21 plus 24 plus 11.5 plus 16.5 plus 23.5 divided by 5, giving us 19.3 millimeters. Now your mean actual length is equivalent to your mean image length over your magnification, which is 19.3 over 12. 19.3 divided by 12 is 1.608333, so 1.61 millimeter, or just to make this better, 1.61 millimeter or 1610 micrometer. But I'm gonna put 1.61 millimeter. That's just one of the options. And for the last but not, we have another paper. Oh my god, I thought I was done. A student suggested that the mean actual length of the vascular bundles calculated in B1 was not accurate for the whole plant. Describe 2 modifications of the method used in B1 to find a more accurate accurate mean length of the vascular bundles of the whole plant. Understanding that this, I'm going to say get different transverse sections of the stem and calculate the mean, or calculate the actual length for all the vascular bundles and find the mean for them and see if it's more similar. So you have a larger value and it's find a mean then, so you divide it, and you can use the EPG, the eyepiece graticule and stage micrometer for a more accurate measurement of the vascular bundles, so that you get you can get the actual length immediately. So those are my answers. Hopefully I get it correct. Measure all the vascular bundles. Take larger magnification. Take more sections. That's not a bad idea. Okay, so from this paper we can see there's 1, 2, 3, 4, 5, 6. So we can say so the transfer sections I took was right. It's just measure all the vascular bundles, because there's multiple that, and they didn't multiply, so vascular bundles and larger magnification. Okay, so another thing is larger magnification. Larger magnification is for easier to see, more high resolution, so measurement is easier. And the last but not least is this one. This one is number 2 is take more sections. So you only took one transverse section, take more sections, so you have more transverse sections of the stem, so larger a larger set of data. So it's the same micrograph. Identify 3 observable differences other than color between section, and K1 record the observable features in an appropriate table. Okay, so it's only asked for differences and not similarities. K1, we take K1 as this. It's on the screen. Let me show y'all right now. K1 looks like this. That's what we took. I really don't have another sample, so this is what we have. This is K1. What we took. This is what they have given us. Okay, what's the difference in this and that? For the K1, the vascular bundles almost form a ring structure towards the outer section of the stem, while in the stems shown in figure 2.3, the vascular bundles find a form